The next part of the question was to find the power values. Let's find the power values of all the vectoral components one by one, and then total power and the sideband power. So let's start from finding the carrier power. Carrier power PC will be nothing but Vc square by 2. Since no resistance is mentioned, we will take RL equal to 1. Vc square by 2 will become, Vc was given as 10, so it's 10 square divided by 2, that will be equal to 50 watts. So we got carrier power as 50 watts. I repeat, we are assuming RL equal to 1. There is no RL given, so we are just finding the signal powers assuming RL equal to 1. Okay, now to find the power in upper sideband 1, which will be exactly same as power in lower sideband 1, we will need the amplitude of upper sideband, lower sideband. So V USB1 square by 2, or I can also write it as V LSB1 square by 2. Now we have written the amplitudes of upper sideband and lower sideband. The amplitudes of both upper and lower sideband is 2.5 volts in both the cases. So this will be equal to 2.5 squared divided by 2. So this will be nothing but 2.5 squared by 2 is 5 by 2 square, so just 25 by 4 into 2 is 8. So that's power in the individual sidebands. Similarly, if we find out power in upper sideband 2 and lower sideband 2, it will be exactly same as 25 by 8 simply because their amplitudes are same, equal to 2.5 volts. We have got power of each and every frequency component also. Now comes the question of finding the total power. Total sideband power will be nothing but sum of USB1 LSB1 power along with USB2 LSB2 power. Because each value is exactly same, it will be simply 4 times 25 by 8, so that's 25 by 2. So total sideband power comes out to be 12.5 watts, and hence the total power in the signal will be carrier power plus sideband power. Carrier power is 50 and sideband power is 12.5, so that becomes 62.5 watts. We can find total power and sideband power using another approach also. I can find out the total modulation index, which is M1 square plus M2 square. Both M1 and M2 are equal to 0.5, so that's 0.5 square plus 0.5 square, and this will be nothing but equal to 0.5 again. So M square comes out to be 0.5. If at all I want the value of M, it will be nothing but square root of 0.5. So now I can find the total power as carrier power into 1 plus M square by 2. Carrier power was already available from its carrier amplitude, so that was 50 into 1 plus M square is directly equal to 0.5, so 0.5 by 2, and this will be equal to 0.5 is half, so this will be 1 by 4. 1 plus 1 by 4 will be 5 by 4 into 50, and 5 by 4 into 50 will give you the total power of 62.5 watts. And once you get the total power, then you can always find the total sideband power also, which will be PT minus PC, and that will be 62.5 minus 50, and that is 12.5 watts. So you can use either this approach of finding total power, or you can also apply the formula directly. But please note that in this formula we need total modulation index, which comes out to be under root 0.5. So that's a complete question with frequency spectrum that we drew in the previous slide, and with all the power related calculations presented here.